Hello and welcome. My name is Jonathan Crabtree, and my talk is How Science Simplifies and Supercharges Primary Level Mathematics Learning and Teaching. I'm going to go very quickly. You'll be able to watch this later on at your leisure. So let's get on with it. I'm looking principally at the connection between science and mathematics. And science, I'm principally interested in the aspect of symmetry. Science is often based on what we see. It's empirical in nature. And in terms of the style of mathematics, science has an affinity with arithmos, which is like applied and practical mathematics, which traditionally was done by workers and slaves. It was kind of like tradespersons' mathematics. If we jump over to the other aspect of mathematics, moving away from science, we often find it's asymmetric, it's abstract, and the philosophy of mathematics associated with our teaching today is ARITHMOI, which is abstract, and it's more appropriate for philosophers. And it's no surprise that some of you may have a doctor of philosophy. And yet it's the philosophy going back to Aristotle which sent the evolution of mathematics down the wrong track. So let's flip things around a little bit and consider that Western mathematics is principally based on ARITHMOI, theoretical abstract philosophy, whereas Eastern mathematics, especially from China and India, is more associated with arithmos, the practical applications of mathematics. So let's move on. I asked a poll on Twitter. It was a 10-second poll, and I wanted to ask people what they thought school children should be taught today. Should they be taught mathematics laws contrary to simple science laws? Or should they be taught math laws that are consistent with simple science laws? We'll get to the results of that in a little while. Now, I'm suggesting that we fix elementary arithmetic because my research into its evolution reveals it to be inconsistent, incomplete, and inferior. Inferior to what, you may ask? We'll get to that. So let's start off with looking at some areas where the mathematics taught in primary schools is inconsistent. We have, for example, the product of two smaller factors can be greater than the product of two larger factors. So -3 multiplied by -4 equals +12. Yet the product of two larger factors, like +1 and +2, is less. That doesn't seem to be that logical, does it? And if we look at the negative numbers there, 3 and 4, those numbers from the aspect of ancient China and India, 3 and 4 are greater than 1 and 2, regardless of the sign attached with them. And we will see that the laws of physics are tending to line up more with the arithmos of China and India than it does of the arithmoi from ancient Greece. So inconsistent arithmetic fractions are equal if they both have the smaller number as the numerator and the larger number as the denominator, or vice versa. So we can see that +2 divided by +4 equals +3 divided by +6. So, and the reason why they're equal is they both have smaller numerators. So if we don't have both fractions having the smaller numerators on the top or the bottom, then they're not going to be equal, as you can see here, because +2 divided by +4 doesn't equal +6 divided by +3. So here's another example. We could have the numerators of fractions, equal fractions, being larger on the top. So positive 4 divided by positive 2 equals positive 6 divided by positive 3. And yet, if we mix up which number is larger and smaller, we see that those fractions are not equal. Now, if we look at this here, we say that positive 1 divided by positive 2 equals negative 1 by negative 2. That's a correct mathematical equality. And therefore, negative 1 has to be less than negative 2, which is not what we actually teach. We are starting to get into the realm of ARITHMOI, where we have a philosophical approach to mathematics which has inconsistencies with common sense and also the laws of science. Because, of course, one negative is less than two negatives. So how's this one? We've got the English definition of multiplication since February 1570 defines AB as A multiplied by B equals A added to itself B times. So to multiply A by positive integral B is to add A to itself B times. And there's the link there. And if I just move my way over to the corner a little bit more. So that means that the English definition of multiplication since February 1570 would have us believe that 1 multiplied by 1 equals 1 added to itself one time, and yet does 1 multiplied by 1 equal 2? Of course not. What we have in the West is we have definitions of our operations which simply do not work. And I've done a lot of research into the formal definitions that are out there and used that simply don't pass either into computer code or into common sense. So let's look at, in terms of inconsistent arithmetic taught in schools, we've got the definitions of A cubed or A to the power of 3. And we see here that of these dictionary definitions, they all say that A cubed or A to the power of 3 is the result of multiplying a number, quantity or expression by itself 3 times. To multiply a number or a quantity by itself 3 times, 2 cubed is 2 multiplied by its 3 times, 3 times 3 times 3 times 3 times 3 times 3 times. And a cube root is a number that can be multiplied by itself 3 times to get a given number and so on. So here we've got all the definitions of A cubed talk about 3 times. But wait on, we have definitions here that say that A cubed is the product of a number multiplied by itself twice. These are dictionary definitions of something as simple as A to the power of 3. Now, when we have definitions from mathematics dictionaries which don't even agree on something as basic as A to the power of 3, we can see that there's never really been an audit done on the logical foundations of mathematics. It's just evolved based on power and influence, and typically the ideas of the elite and the powerful have squashed the often better ideas of indigenous populations. So the British arithmetic is also, I found, to be incomplete. So here I've created a matrix. So I'll zoom it up a little bit here. And what we've got is we've got a matrix where we're testing the teaching of the 4 basic operations with positive and negative 12 and positive and negative 4. And where I've got it shaded in the green, it simply means that the pedagogy is good enough. And where we've got it in the yellow, the pedagogy is currently incorrect in most places around the world. And you can see here we've got a grey cell in that table where we've got the division of positive 12 divided by negative 4, and that is absent. So if we want to know how can it be that positive 12 divided by negative 4 is unexplained, well, we've got the quantitative repeated subtraction model. It fails because if we have positive 12 divided by negative 4, we subtract the subtrahend from the minuend, we're never going to get to 0. So usually what we'd do is, if it was positive 12 divided by positive 4, we'd subtract the subtrahend repeatedly from the minuend until we get to 0 and count how many subtractions we've got to work out the answer. But we can't do that in the case here. So if we switch to the other model of division, the partitive equal groups model, that fails because you can't split positive 12 into negative 4 equal groups. So dodging division to discuss abstract sign laws of multiplication is bad pedagogy, and this child's giving it a thumbs down. So also the British arithmetic, which is typically what's taught around the world, courtesy of the British Empire, is also inferior. So I'm going to suggest that we need to save your school's time, effort, and money by really updating our concepts of the foundations of mathematics. And I've been working on this since 1983. So in 1983, I set out to change the way the Western world teaches maths. And here you can see a newspaper article 5 years after I began. And there's the quote from the newspaper: "I hope to change the way the Western world teaches maths," Jonathan said, and that was from 1988. So here are some of the languages that I've been exploring in my quest to better understand where the foundations of mathematics went wrong. And I've reviewed the history of mathematics from the concepts of ancient Egypt to Greece, China, ancient India, and so on, to piece together why it is that people do not like mathematics today. And it's basically because the ideas are wrong. So switching over, here's the Sanskrit of Brahmagupta from the year 628, and I've analysed and interpreted this to match it with modern laws of science, which is what we're interested in. So ARITHMOI is what led to the teaching of arithmetic in schools all around the world, and it emerged from the ideas of Pythagoras, Plato, Aristotle, Euclid, Nicomachus, and it's basically a philosophy that's demonstrated through abstract geometry, which led on to number theory and successor logic, which many of you would be familiar with. So that's what we've got today, based on the priority that has been given to ARITHMOI, which is working with numbers without any physical concrete units, to simplify. And yet arithmos is really, if we look to the work of the astronomers, and we have practical geometry from Bordiana, Aryabhata, Bhaskara, and Brahmagupta, that leads us to a very different understanding of the elementary mathematical foundations. So let me give you a glimpse at the history of mathematics in one slide. Here we've got Robert Record at the top, and he's saying, in England, my famous 1543 arithmetic book, The Ground of Arts, was followed for more than 150 years, being last published in 1699. So that book, The Ground of Arts, really established the ideas of arithmetic, not just in England, but around the world. Now, unfortunately, Brahmagupta, who documented the laws of zero in ancient India, his zero did not get correctly transmitted through the Middle East. And people like Al-Khwarizmi did not understand the integer arithmetic of India. And zero traveled, but only as a simplistic placeholder, not as the sum of equal and opposite quantities. So zero traveled west, but people like Al-Khwarizmi and the traders in North Africa, Leonardo Pisano, also known as Fibonacci, and Robert Record, they never understood India's original framework of elementary mathematics. And here I've got Robert Record, when supposedly, if he ever found out, I never knew your zero definition, Brahmagupta, or your 18 sutras for zero, positives, and negatives. So we've got a problem in the transmission of mathematics through history, and that's what I've been interested in working out, where the evolution of mathematics went wrong in major ways. So we want to fix the British arithmetic that's taught around the world because it is simply inferior. We can get a sense of that because here's a question. What would you say is your least favorite subject in school? And this is a pretty decent sample size of 2,000 American students in years 10 to 12. And their least favorite subject in school is, no surprise, mathematics at 34%. Interestingly, only 9% said that science was their least favorite subject in school. And again, if we look here, only 1% suggested that computers and technology was their least favorite subject in school. Now, mathematics is typically the most disliked subject in school. And I suggest that the reason is that we are teaching abstract theoretical arithmoi rather than the intuitive and practical arithmos. So really we need to be thinking about concrete instantiations of the original laws of mathematics that emerged in India that never transmitted west. So if we return to this poll, what do you think school kids should be taught today? Math laws contrary to simple science laws, or math laws consistent with simple science laws? It's a landslide victory. What people want is they want consistent mathematics and science laws. Now, mathematics has been said to be the language that describes the universe, and we understand our universe through physics. So if we don't have a language that actually correctly matches our universe, our physical surroundings, intuitively we're going to reject it. And that's what's been happening in our schools. So let's look here. We have the top 3 system constraints of British arithmetic. And I suggest that they are 0, base 10, and fractions. Now, I won't have time to go through these 3 top constraints, but let's just start off with some ideas on 0. The number 1 system constraint, 0. So let's now consider that we've got a closed system, and in our closed system, we had 0 bricks on ocean level 0. Now, then we added bricks to ocean level 0. And so I asked the question, did the ocean rise or fall? And the answer is it neither rose nor fell, because every action has an equal and opposite reaction. So we've got a static quantity of water and solids, and we can see when we create the first brick, we also created a corresponding hole. So just as we created the cube, a solid cube on the surface of the ocean floor, we also created a solid cube of water on the ocean floor. And so as every brick was added, we also have a hole being created. So together here, if we have 10 bricks having been created, as a consequence of Newton's third law and also the principle of the conservation of mass, we must also have 10 holes. And you can see that we've got 10 bricks and 10 holes. So here, in our closed system, we follow the principle of conservation of mass. So 0 has been symmetrically split into equal and opposite quantities. We have, if you want to consider, we have 10 cubes of water in those holes, and we have 10 cubes of solids in those bricks. And the total net quantity has remained the same. We've just simply rearranged our 0 starting point into a sum of equal and opposite quantities, and that is pure Indian mathematics. So the equal and opposite quantities sum to 0. So if we put all of those solids back in those holes, then again we have a pure 0, a net 0. And this is Brahmagupta's laws of mathematics. When positive and negative are equal, the sum is 0. Here we've got a cartoon. Bricks for sale, buy your bricks. And there's Podo the puppy, has 2 bricks for sale. Now along comes another puppy and says, I want 5 bricks, please. Now Podo's only got 2 bricks for sale. So we've got 2 and we want to subtract 5. We can't do it. So as Podo says, I don't have enough bricks, so please come back later. So what will Podo the puppy do? Well, first of all, okay, Podo will say, I have to add 0. Now, that sounds a little bit strange, but it's actually in the Laws of India written by Brahmagupta. I have to add 0. So what Podo the puppy does is Podo adds a 0 in the forms of 3 bricks and 3 holes. And in my time lecturing in India, I teach children how to play the happy Harappan positive brick and negative hole game. So Podo the puppy has now enough bricks. So the buyer can take away the 5 bricks, and what remains are 3 holes. So going through this story, we had 2 bricks minus 5 bricks resulted in 3 holes. If we let the bricks be positive, we can then have 2 positives minus 5 positives results in 3 negatives. Now, this is a very simple model, and what we find is that if we start off our modeling in 3-dimensional metaphors, then go to 2-dimensional, and then 1-dimensional on the number line, we find that we can accelerate our mathematics curriculum by several years with better intuition, understanding, and synchronicity with the laws of science. So there's Podo again from ground level 0. She has dug 10 bricks and created 10 holes. And so she still has, in effect, 10 positives and 10 negatives, which still sum to 0. So we've got from the arithmos through the laws of mathematics as created by India, which never transmitted to the West. It never got to Renaissance Europe or to classrooms today. I've created a different curriculum of elementary mathematics called Podometic, which is based on arithmos. There are units to be considered, and we get rid of all of the inconsistencies that exist currently. And those inconsistencies I've tracked down where they emerged in the history of mathematics. And once you really force yourself to connect the ideas of physics with the mathematics we teach, we start to realize that it's simpler to start again with correct foundations of mathematics that fit the way that the laws of physics work. So from around about 300 BCE to 2020, we've had arithmetic, which has led to students pretty much rejecting it and disliking it. But that's based on ARITHMOI, which is unitless number theory. And if we just switch over to Podometic, which is based on arithmos, which we always have a unit in consideration, which it's impossible to have a quantity of matter or energy that is less than 0. So why would we ever introduce negative numbers as representing counts or measures of quantities that are less than 0 if it's impossible to have matter or energy, quantities of matter or energy that are less than 0? It just is an absurd idea. Negatives are equal and opposite to positives. That's the end of it. Just as a positron and electron come together. One is positive, one is negative. They meet, they cancel each other out with a photon, and they disappear. Well, we have east and west as simply equal and opposite magnitudes. To have a line in which we arbitrarily say that west, a distance of 5 kilometers west, is less than a distance 5 kilometers east is obviously absurd. And I've tracked down how all of these ideas came about, and perhaps that's a discussion for another time. So we now have a branch of elementary mathematics called Podiometic to replace arithmetic, and it's based on physical units.